Hi, I'm Dr. Courtney with the Quantitative Reasoning Center, and I'd like to dedicate this video to Mrs. Cates. And you ask, well, who is Mrs. Cates that I would dedicate this video to her? Mrs. Cates was my 4th grade teacher at T.H. Watkins Elementary School in Lake Charles, Louisiana. And I remember the day that Mrs. Cates helped reinforce for me both the importance of mathematics as a quantitative discipline, the importance of doing my homework, and the importance of being honest with my teacher about whether or not I'd done my homework. And I remember this day we were studying the multiplication tables, and my homework was something related to that, and Miss Cates had read the answers out loud to the class and asked us to grade our homework, and was going around the room asking us what we got on our homework. And she got to me and I said, 100%. And Mrs. Cates said, let me see. And I hadn't really done my homework. I had been lying when I said 100%. So I had nothing to show her. So Mrs. Cates said, step outside into the hallway. And then she said, grab your ankles. And then she delivered with a wooden paddle the appropriate consequences for lying about having done my math homework when I really hadn't. So, thank you, Mrs. Cates. This video is dedicated to you. So, we're having a look at 14.1, number 30, and it says match the function with its graph and to give reasons for the choice. And as it happens, this is a perfect problem to demonstrate the usefulness of Matlab, or possibly Mathematica or Calc Tool 3 if you prefer those technological tools, because if you want to get a look at a surface graph and understand why the function really matches the picture, it can be very useful to graph it together with its contour. So we're going to go over to the computer and have technology help us out with the remainder of this problem. Okay, so we have we have Matlab up and running on the computer, and the first thing we want to do is we want to give a sims x, y real command, because this defines the variables x and y as real variables for the Matlab computer algebra system. And then we can use the command easysurfc, and we want to type in the syntax that represents the first equation, equation A. So it's easysurfc, and then this is the absolute value of x in the Matlab syntax, and this is the absolute value of y. So this will graph that surface function, and it throws that plot up there, and that plot's very nice, and we just compare with the surface functions in the book, and we see that that matches the graph number 6 in the book. And we could also say that it's got the kind of squared off, or the edges that one usually gets at the bottom of a function that includes an absolute value. Alright, let's have a look at number B, or letter B. So this is the absolute value of x times y. So we can enter that with the Matlab syntax, and that would be easysurfc, and the C at the end gives us the contours at the bottom of the plot, and absolute value of x. Oops, that's not going to work because Matlab doesn't know that juxtaposition means multiplication. You actually need to include the multiplication operator, which in Matlab is the asterisk. And so when we plot it there, we can kind of compare this with the different plots in the book and see that this plot matches plot number 5, because anytime either x or y is 0, then the product is 0, and the absolute value of 0 is still 0. So we're expecting this to be 0 all along the x-axis and all along the y-axis as well. Alright, so we can move along to letter C, and here we want to plot an easysurfc, and the function is 1 divided by 1 plus x squared plus y squared where the, take a little care here, y squared, close the paren in the denominator, and then close the paren that matches the easy surf C, and we forgot the F in the easy surf C, and these computer algebra systems aren't very forgiving with regard to typographical errors, so it's better to get it right. So 1 divided by 1 plus x squared plus y squared. Double check our syntax, give it a chance to plot it, and here we see the plot, and that's a little hard to see. It looks like a little bit of a mountain, but a lot of times you can grab it and you can adjust the perspective a little bit and see, yeah, that's probably Roman numeral 1 in the picture, but we can actually adjust the x and y ranges, and if I recall correctly, the syntax for that is putting the 1 comma, well, I think we need -1 comma 1 comma -1 comma 1, and I think that'll adjust the x and y ranges to -1 to 1 as we replot it. So this is a little closer to what's in the book, and the book didn't give us the scale, but I'm guessing if we go back to the easy surf C and we make it -2 to 2 and -2 to 2, then we get something very close to the plot in the book, and we can see now that letter C, the function we just plotted, corresponds to Roman numeral 1, and if you like, you can also adjust the perspective a little bit. Alright, so let's moving on along now to letter D. Is we still want the easy surf C command, and we can still try with those limits now that we've put some limits in, but now the function is x squared minus y squared, quantity squared. So x squared minus y squared, and then we can square that whole quantity and double check our syntax. It looks like all our parens have their matching pairs, and this is the function that we're looking at, and perhaps a little different perspective would help us to see what we're working with here. So the only one that looks like it could be a match is Roman numeral 4, but maybe if we replotted it -1 to 1, -1 to 1, it might become clearer that that's a match with Roman numeral 4. So let's go ahead and adjust our window a little bit. And yeah, that looks a lot more like the Roman numeral 4. So we can conclude that letter D corresponds to Roman numeral 4. Alright, now let's have a look at letter E in problem 30. Let's get the easy surf C command back up here, but let's edit the surface function. And now we want x minus y, quantity squared, and see which one that one might look like there. And that one is looking a lot like Roman numeral 2. So we conclude that that one's Roman numeral 2. And now let's have a look at letter F, which is the sine of the absolute value of x minus, the sine of the absolute value of x plus y. So we want to put in the sine function, and then the absolute value of x plus the absolute value of y. So the sine of that sum is what we want, and that looks like the syntax is correct. And by the process of elimination, because the only picture we haven't matched yet is Roman numeral 3, I'm going to bet that this one looks a lot like Roman numeral 3, but we're probably going to have to zoom out a little bit before we see it very well, because we're kind of zoomed in to -1 and 1. So let's zoom out a little bit to go to -10. Oops. I'm just using the history facility of Matlab here. So if you up arrow, it gives you the previous command, and then we arrow over -10 to 10, -10 to 10, and I'm betting this looks like Roman numeral 3. Get a little different perspective on it. And when we adjust the perspective from different angles, we can see pretty clearly that letter F corresponds to Roman numeral 3. So the technology with Matlab is a powerful tool for quickly identifying surface plots.